Okay, so this should cover this 1.2 advanced notes on page 12 of your packet. So this is right after we did the midpoint and distance. Okay. So we're first going to talk about what a ray is, and how you want to start this is that a ray looks a lot like a line. It's kind of a mix between a line and a line segment. So a ray would look like that. So some important things about it: it extends forever in one direction, only one. Okay, and then this next fact is about how it's named. So it's important that you write it like this. A, B, with a little arrow on top. So we've got some little rays here. They're kind of hard to see, but they're not horrible. You can kind of see them down here. But the A has to be the end point. So you cannot name this ray as BA. That's what's important. So when naming, the end point must be labeled first. Okay? Cool. So that's what a ray is. Now we're talking about unions and intersections and what they are. So an intersection, you guys are probably way more familiar with that term. An intersection is, where things cross, where things overlap. So if we are looking at this Venn diagram, we've got soccer and tennis. So Jade only plays tennis, Alex and Hunter only play soccer, but Casey and Drew play both. The intersection would be which people play both soccer and tennis. So that's the intersection of soccer and tennis. A union is a little bit different. So an intersection is where two sets exist. But the union is where both or either exist. So, for example, the union between soccer and tennis would be all 5 of these people. So it would be Alex, Hunter, Casey, Drew, and Jade would be the union. Alright, so the union would be all 5 people in the Venn diagram. And then for the intersection, it would just be Casey and Drew. Just Casey and Drew. Well, I should probably make their names capitalized, but that's okay. Just Casey and Drew. Alright, so let's talk about it in terms of geometry here. We have ray AB, and this is the union symbol. So notice this is what the union symbol looks like. That's what the intersection symbol looks like. So the union between ray AB and ray BC. So it's basically where either one of them exists at any point in time. Okay? So ray AB starts at A and extends forever to the right. Ray BC starts at B and extends forever to the right. So both of them extend forever to the right, but at least one of them exists starting at A. Okay? So what this would look like is the union of them would be ray AC, but it extends forever all the way to the right, but it has to start at A. Okay? Because it's where at least one of the One of the two exists. Okay, let's look at the same thing, but let's look at the union. So now we want to look at where they overlap. So ray AB starts here and extends forever this way. Ray BC starts here and extends forever this way. So we want to only use, where B starts. So where this ray starts. Because they start overlapping here and then forever this way. So ray BC is where they overlap. Okay, now we're looking at unions again, but we're talking about segments. So just segment AB, so starting at A and ending at B. And then segment BC, starting at B and ending at C. It does not extend forever. Okay, it's that's important, that it doesn't extend forever. From here to here and from here to here, where do they overlap? Where do they touch? That would be the intersection, but we're looking at the union. All right, so where at least one of them exists. At least one of them exists all the way from A to C. So we'd go all the way from A to C. That's the union. The intersection is just where do they touch? Where do they overlap? And they only overlap here at point B. Okay, next is going to be BA. So starting at B and extending forever to the left now. And then it's the intersection of BC, starting at B, extending forever to the right. But they only overlap at one place, right here. They only touch at point B. So this one would also be point B. Okay, but what if you wanted the union? Where does at least one of them exist at all time? Well, one starts at B and goes forever to the left. One starts at B and goes forever to the right. So this entire line, extending forever in each direction, would be where they intersect. And these are rays. Kind of hard to tell, but these are rays. So we've got to remember, how do we write a line from last class? We write it like that with a line over it with two arrows. And the union would be a C. So extending forever in either direction. Okay, now let's look at this one. This one's a little bit different. So it's ray BD, and then the union with ray BE. Ooh, what's going on? What exists here? So we've got this ray, and everything in between. Well, interesting. This is actually going to turn into an angle, because this ray and this ray create the angle BDE. It's not where they overlap, it's the union, and so it's where at least one of them exists. So the only way to write this would be by writing the angles. Angle D, B, E. You could also write it angle E, B, D. That works as well. But these two rays create an angle. Alright. Now let's look at this one, angle ABE. So ABE and angle DBC. Ooh, interesting. I want the intersection of those. So only where they overlap. So ABE goes here. DBC goes here. So we've got this space and this space where they don't overlap, but they overlap here at this angle, from this angle DBE. Okay, so one angle is here, the other angle is here. They only overlap in the middle. Angle DBE. Okay, and then number 9, angle ABE, so that same angle from before, and then angle DBC, same angle from before, but now we want the union. So where do, both of them exist? Or, sorry, where does at least one of them exist? It doesn't have to be where they overlap. And this one's kind of a weird way, because it's everything from here to here. So it's this angle plus this angle, and it's kind of a weird way to write it, but it's actually this entire line, because a line is a straight angle of 180 degrees. So this one's a weird way to write it because you're starting with an angle, but you end with a line, because this entire line is the union of these two angles. Okay, and then the last one was angle ABD union with angle DBE. Alright, so this angle plus this angle is basically what it is, because you are uniting them. You're putting them together. Angle ABD and DBE, when put together, it becomes angle ABE. But what if it was the union of this? So ABD, or sorry, it was the intersection with DBE. The intersection would just be where they touch. So this angle, and they touch at ray BD. Just call that 11. Why not? They touch only there, and so that's the difference between the intersection and the union. The union is kind of like adding them together. The intersection is just where do they overlap. So they only overlap on that ray. All right, thanks.